Hello students, in this video we will study about the cell. We have to understand what is the EMF or electromotive force of the cell. We have to understand what is the terminal potential of cell. We have to understand what is the internal resistance of cell. So first of all we have to understand what is the cell and what is the construction of cell. Okay, when electric current is made to flow through any electric circuit, then in this circuit electric cell or battery is connected. Okay, now in this battery or cell, here electric current is produced. This electric current produced in the cell is made to flow through the conductor, through the any electric circuit. Okay, so we know that the battery or the cell is the source of electrical current. So what is electrical current? Actually electrical current is the electric energy. Means the cell is the source of electric energy that maintains the continuous flow of electric current through the conductor. Okay, now this is the cell. Now we have to discuss about the construction of cell. Look at this. In the cell, here this is a vessel. It may be the glass, or it may be of the plastic. In this vessel, here electrolyte is taken. Okay, and inside the electrolyte, here two electrodes are dipped. Two electrodes are immersed. Okay, first electrode, this is the positive electrode and this is the negative electrode. Here on the positive electrode, here positive potential is there, and on the negative electrode, here negative potential is there. Now here in the between two terminals of the cell, here a resistor is connected. This resistor may be a bulb or calculator or torch, okay, or any electrical devices. Okay, now if this is the key and the resistance of any electrical devices, or this resistor is capital R, this is called the external circuit. Okay, when this circuit is open means here in this key is not there. Okay, now in the open circuit, because this is of the positive potential, this is of here and the negative potential, so here potential difference will be there between two terminals of the cell. In the open circuit, here potential difference between two terminals, two electrodes of the cell is called the electromotive force of the cell. Okay, here, so let this is here on the positive, this anode and this electrode is called anode, and this negative electrode is called cathode. Okay, so let the potential of the positive or anode is represent V plus. Okay, and the potential of the negative electrode or cathode is V minus in negative. Okay, these are the potentials of the anode and cathode. Now, and the potential difference in open circuit between two terminals or electrodes is called the electromotive force. Okay, so here what is the electromotive force? What is the expression for electromotive force? Actually, when current is made to flow through the external circuit by the cell, then here electrons are flowing in the external circuit, and inside the this cell or inside the electrolyte, here when current is made to flow through through the circuit, then here electrolyte dissociates. Electrolyte dissociates electrolytes, or the molecule of electrolytes dissociates in two ions, positive ions and negative ions. Positive ions are called anion, and negative ions are called cation. Okay, because here on the surface of this electrode, here positive potential is there. That's why cation or negative ion will move towards the positive electrode, and here which ion? Negative ion, and positive ion here move towards the negative phase. Okay, and here there are two types of ions. Due to the motion of the ions of electrolyte, here inside the electrolyte, here current will be flowing. Okay, so inside the electrolyte, current is flowing due to the motion of ions, positive ions and negative ions. And in the external circuit, here current is flowing due to the motion or due to the flow of electrons. The current will be along this direction when this electric circuit is closed. When electric circuit is closed, then current will be flowing through the external circuit. Okay, now you know when here cation reaches on the surface of this electrode, then this cation will decrease the potential of the anode. That's why potential on the anode will decrease, and here anion moves towards the negative ion. That's why here the negative charge or the negative potential of negative electrode or cathode will decrease. Okay, now conclusion is that when this circuit is closed, then current will be flowing through the external circuit. Then the potential difference between two electrodes will decrease. So when the current is flowing through the circuit, when the circuit is closed, then current will be flowing through the external circuit. Then the potential difference between two electrodes of the cell is called the terminal potential. Okay, so what is the big difference between electromotive force? Electromotive force is the potential difference between two electrodes when circuit is open, and when this circuit is closed, then the current will be flowing through the external circuit. In this condition, the potential difference between two electrodes of the cell is called the terminal potential. Okay, so what will be the expression for the EMF, electromotive force? You know, when in the circuit here electrons are moving along this direction due to the positive potential. This positive potential attracts the ions. Okay, attracts the ions. That's why here ions and negative potential attracts the positive ion. Okay, so here conclusion that when any unit charge, when this unit charge is carrying in the whole electric circuit, including inside the cell, so work has to be done in carrying the unit charge through the circuit. So work has to be done. So the work done in carrying the unit charge in the whole circuit, including the electrolyte, is called the electromotive force. So what is the definition here? The work done in carrying the unit charge through the whole circuit, including the electrolyte, it is equal to the electromotive force, and it is denoted by epsilon. So this is the formula or expression for the electromotive force. So what is the unit of electromotive force? SI unit. So unit will be work done, means the unit of work done is joule. Okay, and this will be joule per coulomb. Joule per coulomb. So it will be equal joule per coulomb. Okay, but this is actually the potential difference between two electrodes when circuit is open. So this the SI unit will be volt also, volt. So now, since now we have to remember the SI unit of electromotive force is volt. Okay, this is now, and the dimensional formula will be the dimensional formula of work m L square T minus power 2, and the dimensional formula of charge A T. So what will be there? M L square T minus power 3 and A minus 1. This is the dimensional formula of electromotive force. Okay, now what is the potential difference between two electrodes when circuit is open? What will be? Now, when circuit is open, then the maximum potential difference will be there when circuit is open. Okay, here current is not drawn through the circuit. That's why in the open circuit the potential difference between two electrodes will be maximum. So the potential of this anode is plus V plus, and difference minus. Potential on the negative electrode minus V minus. Okay, so the potential difference will be del V equal plus V minus minus plus V minus, or V plus plus V minus. This is the potential difference in the open circuit. Okay, now we have to find the relation between the electromotive force epsilon and the terminal potential. Terminal potential is denoted by V here in this topic, and the internal resistance. The internal resistance of the cell is denoted by small r. But what is the internal resistance? What is the definition of internal resistance? We have to understand here. Okay. So when this circuit is closed, then the current will be flowing through the conductor. In this condition, the electrolyte dissociate the molecules of the electrolyte dissociate in two ions, positive ions and negative ions. When the negative ion or a cation moves towards the positive electrode, then another an ion may be there or there or there or there. That's why in the path of this cation here another ions, the ions may be positive ions or negative ions are there in the path of this cation. So this cation will collide with the other ions. Okay, and the velocity of this cation will not be increased. Okay, and this is the due to the collision between two ions here, the obstruction is offered by other ions in the motion of this ions. Okay, this obstruction inside the electrolyte of the electrolyte is called the internal resistance of the cell. Okay, so what is the internal resistance of cell? Some obstruction is offered. Some obstructions are offered by the ions inside the electrolyte in the flowing of current inside the electrolyte. This obstruction, this obstruction or opposition is called the internal resistance of the cell, and it is denoted by small r. So this is resistance. So we know that the SI unit of resistance is ohm. So the SI unit of internal resistance also will be ohm. So we have to find the relation between epsilon and EMF. This is the EMF, and the terminal potential V, and the internal resistance of the cell is V. So for this, when circuit is closed, in this condition, this end of this resistor and this end of this electrode is connected. Okay, and second end of the resistor is connected to this. So this and this circuit and external circuit are connected in parallel. So the potential difference between the two ends of the external circuit is V, and this potential difference is called the terminal potential. So it will be the potential difference between P and N inside the cell. Let here take a point A on the contact of the electrode of cell and the electrolyte, and take here point B. Here this point is on the contact of this electrode and the electrolyte. Okay, now the potential difference, in the open circuit here or the closed circuit, here the anion and cation will be there, and the density of anion and cation on each points inside the electrolyte will be same. Okay, but here cations are coming to the positive electrodes. That's why the potential will be decreased. The potential of this rod electrode will be decreased, and here potential will be increased. Okay, now that's why at point P and point A, here potential difference will be there. Okay, and let the potential difference between point P and A, the total potential difference between point P and A, the potential difference point A and B, and the potential difference point B and N. We have to add these potential difference. The sum of these potential differences will be equal to the potential difference between two terminals in the external circuit. So the potential difference on the external circuit is V, and it will be equal potential difference between P and A plus the potential difference between point A and B plus the potential difference between point B and point N. It will be equal. Okay, or V will be equal the potential difference between P and A. So you know that the potential difference between P and A, the potential on anode is V plus V. Okay, and the potential difference between A and B inside the electrolyte. Let you know that the current flowing through the circuit, through the out circuit I, that's why, or the external circuit, that's why current flowing inside the electrolyte will same of that I. So here current will be I. So the potential difference will be I into R. Potential difference is current into resistance. So the resistance is the internal resistance, this. And you know that here current is flowing. Current we are going P A to B, but here inside the electrolyte current is flowing B to A. That's why here negative potential will be there. So here minus. Okay, but we are adding all the values. And now here the potential difference between B and N. So what is this? It will be plus V minus. Okay. Now it is equal to V plus and plus V minus and plus minus I into R. But V plus V minus equal epsilon. That's why here V will be equal epsilon and minus I into R. Okay, this is the terminal potential when circuit is closed. In this condition, potential difference between two electrodes of the cell. This is the electromotive force EMF. This is the potential difference between two electrodes when circuit is opened. And this is the potential difference between 2 points inside the electrolytes. So this is the relation. Terminal potential, electromotive force, and this is the current, or this is the internal resistance. So this is the relation between these. Okay, understood? This equation is very important for the numerical solution. Okay, so I hope you would have understood all the concepts. Okay, thanks.